Okay, so we are given provided with question number 1 of the paper 2022, paper 2, mathematics, O level. So the question is reading that given that the determinant of a matrix Q is given by the matrix in the parentheses is given as 15, then you are told to find the value of B and then the inverse of a matrix. So basically, I want to show you, I'll begin by talking about how to find the determinant of a matrix. Okay, so I will begin by just defining what a matrix is. By definition, a matrix is a form of numbers, okay, that has got some entries. So for example, a matrix is always defined by a row and a what? And a column, okay? It is always defined by a row and a column. We have got different types of matrices, but the definition of a matrix is always by a row and a column. These lines that move like this are called the rows. These that come down ones are called the what? The columns. So if I have a matrix like this, let me say A, comma, B. Okay, so the name of this matrix will be, you count the number of rows that are here. How many rows are here? Turn on your mic. How many rows are here in this matrix? Hello? Precious, are you there? Kindly turn on your mic and answer how many rows are here in this matrix. Let's call it matrix A.
Two.
Okay, so if you look at, so the rows are the line that goes this side. These are the rows. Then these that come down are the columns. So how many rows are here? Okay, so you can count, you can see that there is only one right now, that one line that is going to the right. So this is one by how many columns? There are how many columns? There are 2 columns. So this matrix is a 1 by 2 matrix. Is that clear? Right. So again, you may have the matrix like this. Let me write it like this, A, the B. How many rows are in the letter matrix? Let's call it matrix B. How many rows are here in matrix B? Hello, how many rows are in matrix B? The rows are these lines that go to the right, okay? How many are they? So if we count nicely, we'll find that there is 1, there is also 2. So there are 2 rows by how many columns? Only 1 column. So this matrix is said to be a 2 by 1. Then the first one was a 1 by 2. Then if you can have the other matrix, let's have this other matrix here and call it matrix C. Let's have A, B, C, D. This matrix, when you count how many rows are there, you find that there is 1 row, 2 rows. So it's 2 by how many columns? 1 and 2. So this is a 2 by 2 matrix. Is that clear, first of all? Hello, kindly turn on your mic and confirm. I always see with math, I always want to move with you. Yeah, so that you don't remain behind. Are you okay on how to define a matrix? Are you there? Like, kindly turn on your mic and answer, are you still there? So now, how do you define the determinant? Determinant of matrix, a 2x2 matrix to be specific. How do you find a determinant of a matrix? Okay. Now follow nicely. I'm hoping that you're having a book and you're writing somewhere. So if you're given any matrix, any simple matrix, okay? Any simple 2x2 matrix, let's call this as matrix M. That should be of the form. Let me say the entries are 2, 1, 3, maybe and 4 here. To find the determinant, you just have to multiply the major diagonal, this first one that I've written here. You say 2 times 4 minus you multiply the minor diagonal. This one is called the minor diagonal. It's the last one that you multiply, which is 3 times what? 1. And so basically what you will have is, what is 2 times 4? This will give you 8 minus 3 times 1, 3. So that your determinant can be equal to what? 5. Is that clear? Hello? Please feel free to ask questions. Are you fine on how to find the determinant? First of all, I've started from here before we go to the actual question.
Yes, this clear.
Okay, so now we have learned how to find the determinant. Then now, let me show you how we find the inverse of a matrix using this same matrix that we have just done here. How do you find 2, 1, 4? How do you find the inverse after we have found the determinant? Now, follow nicely on how to find the inverse. The matrix is M. It is equal to 2, 1, 3, 4, right? Then we found that the determinant was equal to what? Our determinant was 5. So to find the inverse now, follow nice. To find the inverse, you just say 1 over the determinant. Your determinant is 5. 1 over the determinant, then multiplied by. Now, get this clear. The numbers in the major diagonal here, they swap. Okay? They do swap. So where there is you write 4 here, you write 2. That's the first thing that you do. Once you write, so the first thing to do is to find the determinant. After you've found the determinant, then you have to write 1 over the determinant. Then you multiply by the entries in the major diagonal should exchange, okay, the positions. Is that right? Is that clear? Okay, are we together so far?
Yes.
Okay, if we are together, then these which are in the minor diagonal, 1 and 3, they will just change their signs. They were all positive here, now they will become negative, all of them. Okay? If they were all negative, they could have become positives, all of them. So far, have you heard the steps that are involved in making a determinant so far up to here? We are making the inverse, sorry, the inverse.
It is clear.
Okay, so from here you have to start now multiplying. This number here, we call it a scalar, okay? You start multiplying a scalar by all the entries in the matrix. So you say 1, okay, let me just write so that you're not lost. We'll say 1 over 5 times 4, 1 over 5 times negative 1, 1 over 5 times negative 3, 1 over 5 times what? 2. Have you seen that? Like we are multiplying everything by the scalar. So far, you can copy this up to here. If you have any question, ask me. So there is over invisible 1 here, over invisible 1, over invisible 1, and another invisible 1. Are we together so far? Hello?
Yes, we are together.
Okay. So from here, let's find now let's start multiplying. Obvious. So when you do your multiplications properly, 1 times 4, it will give you 4. Remember, this is a fraction, right? The fractions, you multiply them by numerator by the numerator, okay? Denominator by the denominator. The numerator is the number that is on top of the other. Then the denominator is the one that is down. If you remember the basics of the fractions. So you say 1 times 4, 4 over 5 times 1, 5, right? Then here, 1 times negative 1. What is 1 times negative 1? Hello, what is 1 times negative 1 here?
It's 1. It's positive 1.
Okay. 1 times negative 1 is negative 1 over 5 times 1, whereas this is 5, right? Are you able to follow? Then 1 times negative 3. What is 1 times negative 3? Hello? 1 times negative 3.
It's negative 3.
Yes. Negative 3 over 5 times 1, so 5, right? 1 times 2 is 2 over 5 times 1 is 5. So this is your what? Your inverse. Is that clear? This is the inverse of a matrix. Did you get the steps? I'll repeat the steps one more time. So the first thing is to find the what? The determinant. When you find the determinant, you say 1 over the determinant. Then the entries in the major diagonal should exchange positions. And those in the minor diagonal, they should change signs. And then you start multiplying the entries by the scalar. Is that clear? So far, do I have any question? Hello, do I have any question before you go to the exam question now?
No, to me, no question.
Okay,
I don't know.
let's now move on. We go to the exam question that we have before us. Are you able to see it? It was 2022, it's matrix Q 2B minus 1. Let me copy it. 2B minus 1. The matrix is Q is equal to 2B minus 1 for here. Then it is also negative 3B, negative 5. Negative 3B, negative 5. And the determinant is equal to what? 15. That's what they have told us. They have told us that the determinant is what? 15. So we are told to find the value of B and the inverse of the matrix. How do you find the value of B now? Hello? Are you able to follow so far?
Yes.
Okay. So, you know, you and I know that to find the determinant, the way how they found this determinant 15, they had to multiply the entries of the major diagonal and then minus the entries of the minor diagonal. That's how they found 15. Is that clear? So you say, negative 5 times 2B minus 1, okay? Like you multiply this, then minus negative 3B times 4 is equal to what? To the determinant. And our determinant is already given as 15. Are we clear so far? So in short, you just multiply this and that. minus that times that, then is equal to the determinant you are given in the question now. Because the determinant, they have already found it. So you're not looking for the determinant. Okay. Is that clear? I want you to be writing down and following nicely. You're moving forward now. Are you okay?
Yes.
Okay. Let's start now multiplying clearly. What is negative 5 times 2b? Remember the law
Negative
of expansion. Negative?
10b. Negative 10b.
Negative 10b. Brilliant.
Yes.
What is negative 5 times negative 1? Negative 5 times negative 1?
It's a negative 5.
Okay. So whenever you are multiplying same signs, okay, the answer is positive. Is that clear? Once you multiply the same signs. For example, positive times positive, the answer is positive. Is that clear? Negative times negative, the answer is equal to positive. But once you multiply different signs, for example, negative times positive, the answer is negative. Did you get it? So what is negative 5 times negative 1? Hello, what is negative 5 times negative 1?
It's positive 5.
All right, thank you. It is positive 5. Okay, minus, what is negative 3b
It's
times
positive
4?
5.
Okay, negative 3b times the 4. That will be negative 12b, right? Negative 12b is equal to 15. Okay, it is equal to 15. So when we get there, we can start multiplying now. Negative 10b plus 5 is equal to negative times negative 12, it will be positive 12b, right? Is equal to 15. So when we reach here, what do? We collect like terms together, right? So I have negative 10b plus 12b is equal to 15 minus 5. Why are we saying minus 5? Because this 5 now will cross the equal sign to the other side of the equation. Is that clear? So far, are we good up to here? Are we okay? Hello.
Yes, we are okay. Yes.
Okay, so what is negative 10b plus 12b? Negative 10b plus 12b. What is negative 10b plus 12b? So whenever you are adding different signs, you subtract the smaller number from the bigger one and get the sign of the bigger number. So this is as good as 12 minus 10. So it will give you 2b equal to 15 minus 5 is 10. You divide through by 2 to get b, so that b can be equal to what? To 5. Is that clear? So that's the value of b.
Okay, me, I'm not clear.
Okay.
Where you said negative 10b minus 12b. Are we supposed to say, or are we supposed to write like this? Maybe you say, since 10, it's the one which is at first, and then 12, which is the one which is at the end. Are we not supposed to do so? We will. Oh, aren't we not supposed to say -2 since we've taken from this smaller number, or we just consider it to
Okay.
be a negative, to be a
Okay.
positive, not a negative?
I say that when you're adding or subtracting the numbers of different signs, okay, get it clear. If the signs are different, you subtract the smaller number from the bigger number and you get the sign of the bigger number. You get it, right? Because the signs are different here. There is positive and negative. So just subtract the smaller number from the bigger number. Then maintain the sign of the bigger number. Is that clear? The bigger number is 12, it as positive.
Okay, I've understood now.
Okay. So, okay, to show that you have understood, what is -8 plus 6?
You said -8 plus 6.
Mm-hmm.
It's 2.
2 positive or negative? We are interested in the sign.
It's -2.
Yeah, it's negative. So you got it. You are sharp. Clap for yourself. Okay. So we have found the determinant or the value of B to be what? To be 5. So what we do now, we have a new matrix, the new Q, okay? What will be our new Q? Where there is B, we'll replace by putting what? By putting the value of B, so have 2 times B is 5, minus 1, 4, -3 times what? 5, 5 negative, like that. Are you following? We're getting the new matrix now. Because where there was B, we are replacing now with the value of B. Okay? Are we good? Hi. So you have 2 times 5 being 10 minus 1, that will be 9. 4 and -15. -3 times 5 is -15 minus 5. This is your new matrix Q. Are we together up to here? Kindly confirm if you can hear me.
Yes, we can hear you.
Okay. All right. So from here now, we have a new matrix. We can easily find the inverse, right? We can now easily find the inverse. To find the inverse, I said you say 1 over the determinant. You remember? 1 over the determinant. What is our determinant? What's the determinant?
It's 15.
Yes, so 1 over 15 times Z. What do we do to these numbers in the major diagonal? Hello? Do you remember what we said? What do we do with the numbers in the major diagonal? Swap the position. -5 and 9 here. Right? Then these will change signs. +4 will be -4. -15 will be +15. Is that clear? Are we good up to here?
Yes.
So I've seen that I've now repeated the same thing twice. So let's go ahead and do the right thing. So -4 15, 1 over 15 times -5, it'd just be -5 over 15, isn't it? This will be -4 over 15 and 15 over 15, 9 over 15, right? You're getting lost? No, you are not. So you can say 1 over 5 if you want again to repeat that way, -5. 1 over 5 over 15 times the -4. 1 over 15 times what? Times 15 and 1 over 15 times 9. You remember, I just skipped that stage, you know. You already know it. So we are here. Is that clear? Hello. Hello. Yeah. So what you do from here, you can even reduce these function, these expressions, -1 over -15 over 5 over -5 over 15. We can look for the number that can enter into 5 and 15 without leaving a remainder. We reduce the fraction. What number is that? Hello?
5.
Yes.
5.
So we can get 5. So that will give us -1. 5 into 15 goes 3 times. -4 over 15, there is no number here. 15 into 15 is 1. What about here? What number are we using? Right, so you can use 3 into 9, 3 into 15 goes 5 times. So basically, this is your what? Your inverse. And by so doing, you would have done the needs of the question.